Hi there, this is Renaud Anjoran from CMC, China Manufacturing Consultants, and today I shot a short video on the control plan, also called the process control plan. It's an extremely useful tool that is very common in the auto industry, but we see a lot of other very good manufacturers make good use of it, and in a lot of our projects, a lot of our engagements, our consultants also help the factories put it together whenever we work on the processes or to improve their quality. So here we go, let's go right to the tutorial. This is an example of a process control plan for PCBA operation in the electronics. So these are typical columns and I'll go through them. You might see some different templates, but more or less all of them will be close to this. So a number of parts are purchased from outside, so that's where you will see outsourcing. This is not an internal manufacturing step, but it's good to also include the parts purchased from suppliers here, because then you can see, well, this is a very useful template. Let's go through this one. For example, the diameter of the gearbox for this DC motor. How to check it? Well, we have to measure it. It's got to be 37 mm. Hopefully we will also show a tolerance here. How to check it? Well, with these tools. How often? 10 pieces per lot that arrives from the supplier with sampling. If it's not good, simply return to supplier. This is a D characteristic, meaning it's not critical to quality. It simply get to pass this and basically function, pass these specs, these inspections, and function, and that's good. So no need to check it on many pieces. It's not critical to quality. An A or a B would have a higher sampling frequency. Okay, so all of these parts purchased outside are basically the same. In some companies they don't include them in the control plan. That's fine too. It's useful, but it's obviously not a must. And then here are the main 4 steps that are done in this factory. So let's go through, for example, SMT process. Okay, with what machine? An SMT machine. There's 3 product characteristics that are really important. These 3. How to check them? It's visual. Now it doesn't mean it's manually done by people. There's a vision system in place that does a lot of this visual inspection on 100% of the pieces. Since it's automated, that makes sense. And placement, well, all the little parts need to be in place. Measurement technique is with the text fixture that does this automated testing. It's automated. If it's not good, rework or scrap. Well, it's depending obviously on the kind of issue and its root cause and how easy it is to contain and correct. Okay, the reaction plan. This is very imprecise, obviously, but sometimes can be much more useful. Okay, so 1, 2, 3, 4. Let's take this one for example. So we use an e-test fixture. That's good, but some of this is done by hand. For example, packing in anti-static bag. So the inspection is done visually. It's a 200% inspection, meaning that 2 sets of eyes or the same set of eyes has to check it twice. But anyway, it's a 200% inspection, visual, because it's very fast to check a bunch of these little bags visually, full screening, and if it's not good, again, rework or scrap depending on the severity of the issue. So think of all your process steps inside your company, how to break them down, what product characteristics on the semi-finished products, the sub-assemblies, whatever, treat them as product, and what has to be checked, what's really important, and with what importance. Is it an A, B, C, D? You see, these are just a few suggestions, but you can have a different way of categorizing them. Can you use mistake proofing? Can you use these types of automated testing devices, or does it have to be manual, like for example an operator checking once every 10 pieces, or maybe an in-process inspector coming to check every hour, or there's a lot of different combinations here that you can follow. I hope this is useful. It's a very useful tool, and once it's in place, it requires very little maintenance, but it gives a really precise plan for the production and the quality assurance department to follow. And really the key point here is think of the process controls that really need to be put in place. Check all of this as production goes on. Don't wait until the end and then sort out the bad products and do final inspection. No, end of line inspection is very costly and not very good at catching all the quality problems anyway. And then you have a lot of people doing rework, and this is much better. Think of how to check the really important characteristics, how to check them, make sure obviously that all of these devices or systems are properly calibrated and so on, and that it makes sense. And then that's how your cost of quality, including the cost of all the inspection and testing, will actually go down. Very useful tool. All right, I hope that was useful.